A function f is defined by, write down the equation of the vertical asymptote and the horizontal asymptote. Vertical asymptote only arises when there is division by 0. So we can see that there is denominator x plus 1, and when x plus 1 is 0, we'll have situations that there is division by 0, and hence y value tends to plus or minus infinity, or actually always points at which vertical asymptotes are. These points are excluded from the domain, and actually x is -1 is a vertical asymptote. So answer is that the vertical asymptote is it's a vertical line, hence x is a number. It doesn't depend on y value. X is -1. What about horizontal asymptote? We should consider limit x tends to plus or minus infinity, or in other words, we should consider situation when x is very large positive or negative value, and if x is very large positive or negative, we take into account only the greatest powers of x and ignore all other terms. And here we can see the same order of x in numerator and in denominator, and when x is very large it looks like 2 million over million, and limit is equal to just 2. When the greatest power in denominator is greater than in numerator, then denominator increases faster and y tends to 0, and there will be horizontal asymptote y is 0. When the greatest power in numerator is 1 more than in denominator, there is a slant or oblique asymptote, and if the greatest power in numerator is 2 or more greater than in denominator, then function just increases, and there are no horizontal asymptotes. So horizontal asymptote, it's y is 2. So to find horizontal asymptote, we take into account the greatest powers of x, and if the greatest powers of x are the same, you just divide coefficients. Here it's just 2 over 1 is 2, and also there may be horizontal asymptote if the greatest powers of x in denominator, the greatest power of x is greater than in numerator, hence y is 0 will be horizontal asymptote. Next, sketch the graph, and we also need points of intersection with axes. So let's find y-intercept. So let's consider x is 0. When x is 0, it's y is -1, so 0, -1 is y-intercept, and to find x-intercept we consider y is 0, so we get fraction is equal to 0. It may be only when numerator is equal to 0, and 2x minus 1 is 0, x is 0.5. So 0.5, 0, it's x-intercept or root. And let's sketch the graph. So our vertical asymptote, x is -1 through point x is -1, horizontal y is 2, and actually there are 4 quadrants, and usually such functions like polynomial or polynomial they look like hyperbola, so usually they are in opposite quadrants. And to find in what quadrants they are, we can consider any points. Or actually, it is found that there must be 0, -1, it's here, 0.5, it's here. So it looks like this. It tends to y is 2 and to negative infinity when x tends to -1, and this point is -1 and this point is 0.5. And for x is less than -1, we actually can take any point, for example -2, and for x is -2, we get 2 times -2, -1, -2 plus 1, which is -5 over -1, which is 5. So point is -2, 5. It's somewhere here, and we understand that another part of the graph is here, and also it tends to plus infinity when x tends to -1, and when x tends to negative infinity, y tends to y is 2, and it looks like this. And the next, hence solve the inequality 2x minus 1 over x minus 1. It's actually our function, and it means y. So y is greater than 0 and less than 2, and answer must be in terms of x. So y is greater than 0 and less than 2, it's this branch, it's this part of the graph, and hence answer must be in terms of x. So x is greater than 0.5, because here x 0 is not included, and also 2 is not included, but we can get y is 2 only and infinity, so it's excluded. So x is greater than 0.5, so it's this part, and we can see that for these values of x, y is greater than 0 and less than 2. And the next part, solve the inequality. We can see that it's actually the same, but we have here the absolute value of x instead of x, and it looks like function of the absolute value of x is greater than 0 and less than 2. How to draw a graph, or actually what transformation can be used to draw the graph f of absolute value, or actually how to draw f of absolute value of x when f of x is drawn. The rule is the next. We delete the part of the graph corresponding to negative values of x, and reflect this remaining part for positive values of x about y-axis to the left. So it will be something like this. This point becomes negative 0.5, and also it tends to y is 2 for when x tends to negative infinity. If it's not required here, but be aware that there is a difference between f of absolute value and f of x absolute value. To draw a graph f of x and absolute value of any graph, you delete the part of the graph corresponding to negative values of y and reflect this part about x-axis. So it looks like this. And from the graph we need again find the region for x so that a given function is greater than 0 and less than 2. We can see that again it's greater than 0 and less than 2. It's this part, again this part and this part of the graph, and hence it's for x greater than 0.5 or x less than negative 0.5. So it's here and also here and not included. And that's all for this question.